Hi friends. Today I want to talk to you about absolute value inequalities. And we've talked a little bit about other inequalities, and I also want to remind you about this rule that we learned with absolute value equations, where we've got x is some distance, some range from a central location. So we can apply that idea to the inequalities as well. So here, for example, I've got a graph of x is 3 units away, or less than 3 units away, then from a central location that's 0. It might sometimes also help to think of this as x minus 0 is less than or equal to 3. So here are all of the points that are 3 or fewer away from 0, indicated by this graph. So we've got a range, we could think of this as the intersection, right? It's an and. Oops, not sure what happened there. Delete that. So as I was trying to say, it's an and or an intersection, right? To bring that all together. And I can think about this for some other equations too. Let's take a look at one that sort of builds out of here quite naturally. So for example, if I think of something like the absolute value of x minus 4 is less than or equal to 3. Here I'm interested in the values that are 3 or less than 3 away from 4. So if I think about my number line, I'm really just shifting this number line so that the center's at 4, and I've got the values that are 3 or less than 3 away. So on the number line, I can really see that where my solutions are going to be. So 1 and 7 is what I expect my solutions to be. So let's take a look at how we're going to solve it with an eye to already having an idea of what we're going to expect those solutions to be. So remember that when I solve an absolute value equation, I've got two cases that I have to consider. I've got the positive case and I've got the negative case. But of course, when we deal with a negative case with inequalities, something important happens, right? When I have a negative with an inequality, I have to flip the inequality sign. Okay. So if I'm going to have to flip that inequality sign for the negative case, I need to remember to change it from what it is up here. So the positive case will be x minus 4 is less than or equal to 3, just stays the same. But the negative case is going to be x minus 4, remember the absolute value part will keep the same, is now greater than or equal to negative 3. Okay, this inequality sign here has to flip. So if I solve both of these, here I'm just going to add 4 to both sides. And now x is less than or equal to 7. And if I solve this one by adding 4 to both sides, x is greater than or equal to positive 1. So let's look back up to our number line, and we said that we expected the solutions to be positive 1 and positive 7, and that seems to make sense. So we've got the graph here. I can write the solution set where x exists. Here x appears to be all real numbers. So there exists an x such that x is greater than or equal to 1 and less than or equal to 7. Or I could write this in our interval notation where I've got a straight-lined bracket. The first endpoint is 1, the second endpoint is 7, and that is also an inclusive bracket on the close. Okay, so different ways to write that same solution. So if you've got an absolute value that's less than something, it's going to be an and, it's going to be an intersection, right? Because we're talking about all of the things that are in between those two endpoints. So let's take a look at the next case here. So here we've got an absolute value of x is greater than or equal to 3. And again, remember, we can think of that as x minus 0. The absolute value of x minus 0 is greater than or equal to 3. Because we're talking about all of the points on the number line that are more than or equal to 3 points away from 0. Well, 4 is more than 3 points away from 0. 5 is more than 3 points away. So it's all of these and all of these. So if we take another case, I don't know, maybe this time we'll take a negative, we'll shift it the other way. So let's say we've got x minus negative 2 is greater than or equal to 3. And you'll usually probably see this written as the absolute value of x plus 2 is greater than or equal to 3. So we're going to think about this the same way. So if I think about it on the number line first, I'm going to consider, well, hey, this is going to shift on the number line to negative 2, right? Because my middle is negative 2. Okay, and now I'm talking about all of the things that are 3 or more away from negative 2. So I expect it to be everything less than or equal to negative 5, and everything greater than or equal to positive 1. So let's go ahead and see if we can solve that and show that case. So starting from here, I'm going to have the a equals b positive and the a equals negative b negative case here. So x plus 2 is greater than or equal to 3. And in the negative case, x plus 2 is, don't forget to flip for the negative case. So x plus 2 is less than or equal to negative 3. Okay. So now solving, I subtract 2 on both sides. So x is greater than or equal to 1. And over here, I'm going to subtract 2 from both sides. And x is less than or equal to negative 5. And notice they're going in opposite directions. So this is an or statement. Okay, so that's an or statement, or we might also call it a union. So when we write the solution set, we might write that we're talking about the set of all x such that x is less than or equal to negative 5, or x is greater than or equal to positive 1. Okay. I just rearranged the order there so it sort of went in the same order you think about it on the number line. And in our interval notation, so this is set builder notation here, in our interval notation, I've got it goes all the way down to negative infinity. So negative infinity, non-inclusive, of course, because I don't really know what negative infinity would be. And it goes all the way up to negative 5, and that is inclusive on negative 5, so square bracket. And it's a union, so it's one or the other. Remember, in every good union, both sides go their own way, sometimes at least. And so the other one is a solid bracket at 1, and it goes all the way up to all of the numbers, non-inclusive bracket to close because it's infinity. Okay, so there we have 2 examples of how we're going to solve, how we're going to tackle these absolute value inequalities.